In this video, we're going to look at the graphs of trig functions. We're going to look at how we transform them, look at amplitude, period, phase shift, vertical shift, similarities between translations of trig functions and the functions we've looked at before, looks at graphs of tangent because they're different, and talk specifically about how sine and cosine differ from tangent. So first off, we have amplitude. So this right here is the generic function for trigonometry, where f here is your trig function. So it could be sine or cosine. Okay, so A, the number in front, is the amplitude. Amplitude is the height of our waveform. So amplitude is from 0 to our height. That's the amplitude. Okay, your amplitude is usually measured in positive because the trig functions oscillate from above the midline to below the midline, so it's the absolute value of A. The other way you can do it is if you know the if you know the maximum and the minimum, you could subtract the two. So in this case, we're going to get 10 minus negative 10 times 1/2. So our amplitude is 10. And we could get that just from reading the graph in this case. But that is amplitude. It is the height of the waveform. For most things, amplitude is the signal strength. So the stronger the signal, the more powerful it is, the higher the waveform. If you're used to radio stations saying they have, the watts that they have in their transformer, that's because that power means they can transmit a more powerful waveform, which is a taller amplitude. Next we're going to look at is the period. The period is related to the b in our function. A period is from one peak to the next peak of the waveform. Okay. The period of sine and cosine unmodified is one circle. So 360 degrees or 2 pi. For tangent, it's going to be 180. So to figure out what your period is, you take your principal period. So if it's sine or cosine, you take 2 pi and you divide it by b. And that gives you your principal period. Now, we will talk about periods in our problems, but in the real world, most of the time we talk about frequency, which is 1 over the period. So it's going to be b over 2 pi or b over 360. Okay. What that represents is the cycles in a given time interval. Usually it's cycles per second. So if we look at our example here, one cycle goes from here to here. So this occurs at slightly before 1, and then we'll say that's slightly before 4. So our frequency is 1 cycle in 3 seconds. Or cycles per second, which is frequency. It's measured in hertz. It's Hertz, is in hertz. So you're used to hearing that. When you tune the radio, if you still listen to the radio in your car, you're tuning to the frequency. So when you're listening to the radio station that is, say, 106.5, that's 106.5 megahertz. So that's 106 million times per second that waveform is oscillating back and forth. So let's figure out the amplitude and period of the following functions. So for this one, remember, we're going to look at a. It's the number in front of our function. So amplitude is 2. Amplitude is 1. And then the period for these, we're looking for b, which is in front of our x. So our period is going to be 2 pi over 3. And our period in this case is going to be pi or 180 because it is 1x. The next thing we're going to look at is our shifts and translation. So this is moving the trigonometry function upward, down, and left and right on the graph. So a phase shift is a left to right shift of our function. And that's characterized as the c in our function. Just like we have been looking at with our functions, is that the number inside is opposite what we expect and moves it left or right. And then the vertical shift shifts the midline, shifts the 0, quote unquote, of our trigonometric function up or down. And that's characterized by the d in the function. So let's look at these. So I'm going to start with what cosine looks like. So cosine starts at 1, at 0. So let's call this 1, 2, 3, 4. So this is 2 pi. This is pi. Pi over 2. 3 pi over 2. And at pi, we're at -1. And at 2 pi, we're back up. And then we cross here. Okay, so that is cosine of x. Now we need to look at 2 cosine of x. So that means our amplitude has changed from 1 to now 2. So we're going to go from up here to down here to back up here. Same basic shape, just a steeper fall. Next, we need to look at 3 cosine of 2x. So now instead of 1, we have 2 of those functions, and we go all the way up to 3. So something like that. And then we need to do a different graph for g. So sine starts here and goes up, down, comes back up. So sine of x minus 45. So this is 45 degrees right here. No, this is 45 degrees right here. And it's going to be a right shift of 45 degrees. So what that means is our function is we're gonna take our orange function and move it to the right 45 degrees. So it's gonna look something like that. Now let's see you try. So the first thing we're going to do is graph 2 sine. So we've got 1, 2, 3, 4. So it normally looks like that, but this particular one is going to look like that. We've got 2, and then we're looking at y equals 1 plus cosine of 2x. So again, cosine's going to start here and go like that. But we're going to do it twice. And then we're going to shift it 1 up. That's getting really... So let's see which ones we don't need. So I've got to shift it up 1. So I don't need that one. Don't need that one. Don't need that one. So those are the 2 functions, roughly speaking. Now, part B says state the number of solutions of those 2 equations between 0 and 360. Well, this is 360 right here. So let's state the number of times they cross. They cross once, twice. And that's going to get us set up for our next section. So we're looking at tangent. Tangent is different. Okay. Tangent has asymptotes, meaning a line the function doesn't cross every 180 degrees or every pi. So that's what these dotted lines represent, is the asymptote. So our tangent function starts at negative infinity, climbs, turns, crosses 0, and then goes back up towards positive infinity. Okay? Tangent can have an A, but it doesn't really have an amplitude. The A just changes the shape. It doesn't have amplitude in the way we think of it for sine and cosine. So if you're graphing tangent, remember that it's this S curve, and it's this right here is 0, 0. So it starts at 0, swoops up to pi over 2, and then resets. So in this video, we looked at transformations of trig functions, specifically amplitude, period, phase shift, vertical shift. We hinted at and we talked about the similarities between the translations, between function translations and trigonometric translations, and we briefly looked at the graph of tangent. Again, here's your homework. If you struggled with stuff in this video, find the additional support page that goes with this particular video or pages. There might be more than one, and work a problem or 2. Some of them will work in class. Some of them because they're the practice problems in here. Some of them we won't. But these additional support problems on top of these 4 can be helpful to you. The other place you can seek help is in ALEX. ALEX isn't going to necessarily prepare you for the AICE exam, but it is going to give you the rote practice on material needed to do the basic mechanics of the Cambridge problems.